Welcome to second year students. Already we have discussed the chapter matrix. Today we shall discuss about the determinants. Very easy, and also this is in unit 2, matrix and determinant. And student can score out of 20 to 20 in this unit. So carefully we have to remember the properties of determinant. What do you mean by determinant? How we expand the determinant? Today we shall discuss this type of questions. First, what do you mean by determinants? Determinants. And what is the basic difference between the matrix and determinant? Determinant is a particular value, but matrix is not a value. Matrix is the arrangement. Some data or some elements we arrange in row and column is known as matrix. But determinant is a arrangement with a particular value. That is the difference between matrix and determinant. And a determinant is a equal number of rows and equal number of columns with a particular value is called a determinant. So, arrangement of square number of elements, arrangement of square number of elements in equal number of rows and columns with a particular value that is important. Matrix has no value. Matrix is only the arrangement. But determinant is a value. Determinant is a particular value. We have arranged in equal number of rows and columns. So, arrangement of square number of elements means 1, 4, 9, 16, 25. These type of elements can form a determinant. But any number of elements can form a matrix. With any number of elements we can form a matrix. But with any number of elements we cannot form a determinant. For a determinant we need square number of elements. So a square number of elements which arrange in equal number of rows and columns which has a particular value, that is important, which has a particular value is called a determinant. Generally, second order determinant represented as A11, A12, A21, A22. This is a second order determinant. A11 means it is the element of first row, first column. A12 means element of first row, second column. Second row, first column. Aij means the entries of ith row and jth column. Ith row and jth column. That is Aij. Similarly, first suffix represent for row number and second suffix represent for column number. So that is the general representation of a second order determinant. Similarly, we can represent third order as A11, A12, A13, A21, A22, A23, A31, A32, A33. This is the general expression of a third order determinant. This is a second order determinant. So far our course is concerned, we are acquainted with only second order and third order determinant. But there are fourth order, fifth order, sixth order determinant. but we are least concerned about that, because our course, our question are mostly acquainted with the second order and third order determinant. You have already known how to expand the second order and also third order determinant. The second order determinant A1, B1, A2, B2. Suppose if this is a second order determinant, it can be expanded as A1, B2 minus A2, B1. Already all the science students are acquainted with this expansion, because in cross product of the vectors we are evaluate or expand a determinant in first year also. This is the only way we can expand a second order determinant. But a third order determinant can be expanded in 6 ways, either in first row or in second row or in third row, or by first column, second column or third column. So a third order determinant can be expanded in 6 different ways, but it is a unique value. It does not differ for different expansion. Only we can expand in 6 different ways. Suppose this is a third order determinant. So a third order determinant can be expanded in 6 different ways. Either we can expand in first row or in second row or in third row or in first column or in second column or in third column, but the value is remains same. Suppose we expand it first row. About first row we can expand it as A1. We have to delete or discard this row and this column. Then we will get a second order determinant B2, C2, B3, C3. Then here it is plus, minus, plus. Minus B1. Then we have to delete second column, first row. A2, C2, A3, C3. Plus C1 into A2, B2, A3, B3. So which is expanded as A1 into B2, C3 minus B3, C2. Minus B1 into A2, C3 minus A3, C2. Plus C1 into A2, B3 minus A3, B2. In this way we can expand in first row, in about also second row, third row and first column, second column, third column. So a third order determinant can be expanded in 6 different ways, but a second order determinant is expanded in only unique way, that is A1, B2 minus A2, B1. This is a particular value. So determinant is a value, not arrangement. We arrange this value in row and column, in equal number of rows and columns. But matrix has no value. That is the basic difference between matrix and determinant. Determinant is a value which arrange in equal number of rows and columns. But matrix is a only arrangement of elements in rows and columns. And any number of elements can form a matrix, but square number of elements form a determinant. This is the basic difference between the matrix and determinant. This is all about the expansion of a determinant. For particular example, suppose the determinant is, generally we denote the determinant as delta. 1, 2, 3, 2, 1, 5, 3, 2, 7. This is a third order determinant. We can expand this third order determinant in 6 different ways. Suppose I expand it about first column. About first column, we can expand this as 1 into, we have to delete first row and first column, then we will get 1 5 2 7. Then next element is 2, that is minus 2. We have to delete second row and first column, 2 3 2 7, plus 3 into, we have to delete third row and first column, 2 3 1 5, which is equal to 7 minus 10 minus 2 into 14 minus 6 plus 3 into 10 minus 3, which is equal to minus 3 minus 16 plus 21, which is equal to plus 2. This is the particular value of the determinant. So in this way we can expand a third order determinant. Third order determinant can be expanded in 6 ways. This is all about the what do you mean by determinant, how we can expand a determinant. Then we shall discuss about the minor and cofactor of a element of a determinant. What is minor and what is cofactor? Minor and cofactor. Minor and cofactors. First we shall discuss about the second order determinant, then for the third order determinant. What is the minor and cofactor of a determinant? Suppose a determinant, for a particular example, determinant is 1 2 3 5. This is a second order determinant. First we have to find the minor of 1. Suppose here 1 is the element of first row and first column, then the minor of this 1 is denoted as M11. M for minor, 1 for first row and second suffix for column. That means M11 means the minor of 1, which is equal to, we have to delete the elements of first row and first column, we obtain 5. So minor of 1 is 5. Very easy. We have to first delete the element of that row and that column, and which determinant we obtain is the minor of the element, that is M11. Suppose we have to find M12. M12 means minor of first row and second column. First row, second column. That means for 2 only. Then we have to delete this row and this column. Then we obtain 3. So minor of 2 is 3, and which is denoted as M12. Similarly M21. M21 means second row and first column, that is 3. So minor of 3, we have to delete second row and first column, that is 2. M22, that is minor of 5, which will be 1. Very easy. This is for second order determinant. This is all about the minor. Next, cofactor, and we denoted as C11, means cofactor of 1. That will be minus 1 to the power row plus column into M11. That is the basic formula to find the cofactor. Minus 1 to the power row plus column into its minor value. That is equal to minus 1 into 2 into 5, which is equal to 5. That is the cofactor, and it is very important. Whenever we will find the inverse of a matrix, it is basic need. We have to find the minor and cofactor of all elements of a matrix. So next, C12, that is minus 1 to the power 1 plus 2 into M12, that is minus 1 to the power 3 into 3, which equals to minus 3, because minus 1 to the power odd power is minus. Similarly, C21, that is minus 1 to the power 2 plus 1 into M21, that is minus 1 to the power 3 into 2, that is minus 2. Similarly, C22, minus 1 to the power 2 plus 2 into 1 M22, that is minus 1 to the power 4 into 1, that is 1. This is all about for the second order determinant, how we can find the minor and cofactor of each element of a second order determinant. Then now we shall discuss about the third order determinant. Process is same. Consider a third order determinant as 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a third order determinant. How we can find the minor and cofactor of each element of a third order determinant? So consider the element 4. So this is a element of second row but first column, means M21, second row first column, that is the minor of 4, which is equal to minor of 4. Minor of 4 equals to, we have to delete the element of the second row and first column. We will obtain a second order determinant 2, 3, 8, 9, which is equal to 18 minus 24, that is minus 6. This is the minor of 4. Similarly, we can find the element of other also, minor of other elements. Then C21 means cofactor of 4. Cofactor of 4, same formula, minus 1 to the power row plus column into M21, that is minus 1 to the power 3 into minus 6, which is equal to minus 1 into minus 6, that is 6. In the same manner, you can also evaluate the minor and cofactor of each element. That is the process how we can find the minor and cofactor. Let us now write the general definition for minor and cofactor. What do you mean by minor? Minor. The minor is the minor of element Aij is the determinant obtained by deleting the elements of ith row and jth column. We have to delete the elements of ith row and jth column, then which determinant will obtain is the minor of Aij. We denoted it as Mij, that is the minor for the element Aij. Aij means the entries of ith row and jth column. Next, cofactor. The cofactor of Aij denoted as Cij, where Cij equals to minus 1 to the power I plus j into Mij. That is the general formula for minor and cofactor, and practically we discuss through the examples. So this is all about the minor and cofactor. Next, the important fact is properties of determinant. There are 7 properties in our book. We shall discuss one by one. Then we will go to solve the exercise. And matrix and determinant is a 1 unit, and in council examination 20 marks will come from this unit, and it is the most easiest unit for the +2 science students. You can prepare yourself. Next, properties of determinant. Properties of determinants. Properties of determinant. 1. The determinant remains unchanged if we change corresponding rows to corresponding columns. That is the basic fundamental properties of the determinant. Means if we change corresponding rows to corresponding columns, that means first row to first column, second row to second column, and third row to third column, then determinant remains unchanged. Means its value will be as usual same. That is, a determinant remains unchanged. A determinant remains unchanged by changing its corresponding a determinant remains unchanged by changing its corresponding rows to corresponding columns. A determinant remains unchanged by changing its corresponding columns to corresponding rows to corresponding columns. That means suppose a determinant of third order is A1, B1, C1, A2, B2, C2, A3, B3, C3. Suppose the third order determinant is this. If we expand about first row, this will be A1 into B2, C3 minus B3, C2 minus B1 into A2, C3 minus A3, C2 plus C1 into A2, B3 minus A3, B2. This is the value. This value is the determinant, and we expanded about first row. Suppose del 1 is a determinant, we change its first rows to first column. Here first row is A1, B1, C1. Here A1, B1, C1 will be the first column, and second is A2, B2, C2, and third is A3, B3, C3. Suppose we expand this determinant as first column, because we know that if you expand a third order determinant in any way, the value will remain same. So if we expand about first column, it will be A1 into B2, C3 minus B3, C2. Next B1 into A2, C3 minus A3, C2 plus C1 into A2, B3 minus B2, A3. This is all about delta 1. Here delta is same as delta 1. Del is same as del 1, no change. So if we change corresponding rows to corresponding columns, determinant remains unchanged. The value will remain same. This is the basic properties of a determinant. If we change corresponding rows to corresponding columns, the determinant remains unchanged. This is all about the properties 1. You have to remember these properties. There are 7 properties, and using these properties we can evaluate determinant without expanding. In council examination, mostly questions will come how to evaluate a determinant without expanding by using properties. That is important. Next, properties 2. Properties 2. If any two adjacent rows or columns will interchange if any two adjacent rows or columns will interchange, then sign of the determinant will change without changing its numerical value. That is properties 2. If you interchange, if any two adjacent row or columns will interchange, then sign of the determinant will change without changing its numerical value. That means, suppose del is a1 b1 c1, a2 b2 c2, a3 b3 c3. Suppose this is a third order determinant, and del 1 is we interchange second row as first row and first row as second row. That is a2 b2 c2. Here it will be a1 b1 c1, a3 b3 c3. Now we interchange row 1 to row 2 and row 2 to row 1. Then according to these properties, del 1 equals to minus del. That is the properties 2. If we interchange also column, similarly if we interchange any two adjacent columns, then the sign will be changed. For particular example, suppose determinant is 1 2 3 4 5 6 7 8 9. Suppose this is a determinant of third order. If we expand it, then its value will be 45 minus 48 minus 2 into 36 minus 42 plus 3 into 32 minus 35, which will be minus 3, and it will be minus 6, that is equal to plus 12. It will be 9 minus 9, sorry, it will be 35 minus 30, 32 minus 35 minus 3 into 3 minus 9, that will be 0. Sorry, take another examples. 1 2 1 2 3 5 2 2 1 3. Suppose this is a third order determinant. We expand it as 1 into 9 minus 5 minus 2 into, that is 6 minus 10 plus 1 into 2 minus 6, which will be 4 plus 8 minus 4, that is 8. This is the del. Now take del 1 as Now interchange first column to second column and second column to first column. Means 2, 3, we will get minus 8. Here del is 8, but del 1 is minus 8. Only the sign change without changing its numerical value. That is properties 2. Means if we interchange any two row or column, then sign of the determinant will change without changing its numerical value. That is properties 2. Next, properties 3. Today we will discuss 3 properties, and next class we will discuss other properties and also examples how we can solve the problems without expanding by using the properties. That is properties 3. A determinant will be vanishes means 0, will become 0. A determinant will be vanishes if any two rows or any two columns are identical. That means if any two row or columns are identical, means either they are same or proportional or some multiple, then determinant will be vanishes. Means suppose determinant is A1, B1, C1, A2, B2, C2, and here it is A1, B1, C1. Then del equals to 0. Means here the first row and third row are same. So determinant is, without expanding we can write it will be 0. That is the properties 3. Any two row or any two columns are identical, then determinant will vanishes. For example, suppose determinant is like that, like this: 1, 2, 3, 10, 20, 30, 7, 49, 86. So directly we can write it as 0, because first row, if we multiply 10 in first row, we will get second row. So first row and second row are identical. So without expanding we can write it as 0. That is properties 3. Either it is multiple or same or proportional, that determinant will vanishes. That is properties 3. Out of 7 properties, today we discuss 3 properties. In next classes we will discuss other properties and also examples, so that you can solve the problem in your exercise. Thank you all for joining the class. In next video we will discuss the other properties. Okay.